Okay, I want to go through some ideas of what's going on with parabolas and reinforce that. If I've got a root at 0 and say a root at, let's go say 4, so you've got 0 and 4. We want to get that area there, but before we get that area, what's the equation of that parabola? Ben, come on, see if you can focus for them. What's the equation of that parabola?
Negative.
Yes.
X bracket
Well,
X take 4.
X.
Yeah. So if it goes through at 0, it's just an X. If it goes through at 4, it's a -4, and it's an upside down.
But it could be dilated, couldn't it?
Yeah.
Yes. Thank you. So let's deal with cases. Let's make life easy. Let's make A equals 1. What do I mean by A equals 1?
Okay.
That's going to be a 1 and a 1, or -1 and -1, whatever you want it to be. You can't really go -1 and -1, but one of them being minus means it's upside down. You okay?
Yep. So
that makes life a bit easier. Going A equals 1, and I like it, mate. Otherwise, you need to put in a point and figure out what's going on. You good? You good at it? I'm impressed. So that's minus x squared plus 4x dx. You right? So what are we going to get? The area under the curve between there and there. Anyone sort of, nah, we won't guess what it is. From 0 to 4. How do you do the question? Come on, tell me, Ash.
How do you differentiate it?
Yeah, which is minus.
Minus x3 over 3 plus 4x2 over 2.
Plus a c, but you don't have to write the plus c if you're going from 0 to 4. So it's what we call, I haven't nagged about it, this is a definite integral. What do we mean by definite integral? Does someone have a go? What do we mean?
is it from 0?
Not because it's from 0, but that's logical. I like it. By the way, if I made it from 1 to 5, it wouldn't be from 0.
Yeah.
So I could do the same parabola and move across one there. It's not about that. Yes, mate.
There's no c.
Hey?
There's no c.
Yes,
Like we know that it's.
that's true. That's part of it, but it's not necessarily the understanding of what's going on.
Is it because it's between the x intercepts?
And it's not necessarily because of the x-intercepts, it's because it's from one point to another. So we've got a starting point and a finishing point. We're actually getting a number for that area. Okay?
So wait, so you could have 0 to 3?
Yeah.
And then that would still be a definite integral.
Yeah. So you could even go, if you wanted to, you could go from say 1 to 3. Yeah? And that would be that area just there.
Yeah. What would be a not definite integral then?
Well, there's what we call indefinite integrals. So if I tell you to anti-diff, I don't know, diff, what?
Oh, like 0 to infinity.
Yeah, y equals, no. Just if I say anti-diff y equals x squared, what's the anti-derivative of that?
3
X cubed on 3 plus c. Now, c doesn't have a value at this point in time, so that's called an indefinite integral.
Oh, so it is the plus c.
Yeah.
Yeah.
So when you don't know where you're starting and finishing, it's an indefinite. When you know where you're starting and finishing, it's a definite integral. Now, something that's going to come in a second is some of the definite integrals will be the area and some won't be the area. So I'm going to take a fair bit of time on this, Ben, if I can keep your brains connected. Yep.
There could still be a c though, right? But like we know what it is.
If you knew some values, you could work out what the c was. So if you know the graph went through, I don't know, 1, 5, you can work out what c is for 1, 5. So let's go look what it is then. What are we doing when we calculate this thing?
Anti-differentiating.
Yeah. So what are we doing when we're any differentiating, Mac? See if you can concentrate, mate. We're substituting two numbers. What numbers are we substituting?
X values?
Hey?
X values?
Yeah, which two for this one?
0 and 4.
Yeah. So we substitute 4 and we get a minus of 4 cubed on 3 plus 4 by 4 squared on 2. Yeah? Then we go minus what? Let's go slow. 0 cubed on 3 plus 4 times 0 squared on 2, and all of that's just, Ben, you're drifting, mate. 0. So what's that? 4 cubed? Oh, it's yucky numbers, I should have picked better ones. 4, 16, 64 on 3. What's this one?
64 on 2.
64 on 2. So in reality, it's 64 on 2 minus 64 on 3. Shall we figure out what that is? Yes, let's do it. That into that is 32. That into that is
20 point
20,
3.
20,
Oh, 21.
21. 21 and the third?
Yep.
So if I subtract those two, what do I get?
It's 11.
Not quite.
10 and 2/3.
10 and 2/3. Now some of you just see the 10 and 2/3. What the hell is 10 and 2/3 got to do with what's on the diagram on the board?
That's an area.
That's the area. So we're talking about area, and that area there is 10 and 2/3, which is amazing. One of the things I like about parabolas is how often they turn out to be nice fractions. By the way, not necessarily nice repeating decimals, but they're usually thirds and 2/3, commonly, yeah.
Is it 10 and 2/3 units squared?
Yes. So an integral can be the area, you're right? What happens if I do the integral that way around though, for the 0?
Yeah, this is.
Now this is the important stuff, this makes people's brain up and they love to talk about this in a theoretical way in the WACE exam. Give you a diagram and get you to explain your understanding, and people go wrong. Because people know how to put the numbers in like when I was at school, but they don't know the understanding. Yeah, mate?
Is any of this related to the area of the sphere?
Of a sphere,
Yeah.
it's an area of anything. So I could actually get the area of a semicircle. I could put a semicircle from there up to there and down to there, and I could get the area of that semicircle. But I can't get, with your present understanding, the area of a circle, because it's another function. It goes up and then it comes back under itself again.
Oh.
But I could get the area of a semicircle. Okay, you two. So what's that going to be? If this turned out to be 10 and 2/3, and if I was fussy, like you said, mate, thank you. So unit squared. Yeah, that's the minus of it. So instead of going 32, take 21 and a third, it's going to be?
21 and a third, take 32.
Yeah. It just reverses all the numbers around. So this will go to the front and that will go to the back, so we'll just get a negative of it. So this one will just be the negative of 10 and 2/3, unit squared. And is it right to call it unit squared? Can we get a negative area? No, but in reality, if I get a negative area, I know it's just the positive area. So some people will talk about it and put in absolute values and everything. So minus, what did I say? 10 and 2/3. Okay, so I won't write unit squared on that. So what else can we do with this question? What can we go? What happens if I turn it upside down? So let's talk about this as, we could say this is case 1 maybe. What about case 2? What is it about case 2? What am I doing? They are reversed. So what does it do to the question? If it was positive, it makes it negative. Right, what if I go upside down? Case 3, upside down. Now I'm going to test these when I missed. I want the same graph as that. Turn it upside down.
And you just take the negative?
Yeah. Get rid of the negative. So now I'm going to get the integral of the upside down. That's this one here now. Obviously, what is it going to be?
10 and 2/3.
Yeah. Now, will it give me a negative 10 and 2/3 or will it give me a positive 10 and 2/3 because it knows it's under the x-axis? It's obviously going to be 10 and 2/3. Do the figures? How about I do it? You just watch. We're still going from 0 to 4, aren't we? Nothing's changed on that. And we've got x squared take 4x. You can see it's all the same calculation. So what's that going to be? Still going to be x cubed on 3. Oops. Minus what? Who can see that in their head now? It's 2x squared. So you go squared on 2. So in your head, I've seen some students will put a little square on a little 2 and go 2 into that's 2. That's 2x squared. Yeah? From 0 to 4. Do we have to worry about the calculation of the 0? No, because that'll become 0, that'll become 0. So what do we have? 4 cubed on 3 minus 2 by 4 squared. We're back to where we were. Oops, have I made a boo-boo?
No.
2x squared. Over here, I didn't bother to write that as 2x squared. Like seriously. Doesn't matter if I didn't. So what have I got? 64 on 3 minus 32. So I've got 21 and a third minus 32. What's it done to my calculation? So if you reverse the numbers, it makes it negative. And if you turn it upside down, it makes it negative. Yes?
Would we lose marks on the test if we subtracted in the wrong direction and got a negative answer?
If it said, what's the area of the following, and you wrote it as a negative, you'd probably lose a mark.
If we correct it though, does it count? Or
I can't see you losing any marks. I don't actually know, but I can't see you losing any marks.
if I got like negative 10, 2, 3, and then just went equals 10, 2, 3.
Yeah. Oh, by the way, if you calculated that like that and you got the negative answer of negative 10 and 2/3, and it said what was the area, what do you do with it? Now, what happens if you put this in your calculator and you don't want it to be a negative answer? How do you do the question? What sign, what symbol do we use to say I don't want a negative answer? So we haven't spent enough time on
yeah. Magnitude, what's it called?
magnitude, absolute value. So if you pick up your calculator for a second, and you say, you know there's going to be negative 10 and 2/3, yeah? If you put that symbol in there, what does it do to it? What if you put the symbol in here, what does it do to it? So can you grab your calculator for a second? Do it that way, get an answer. Do it this way, and get an answer. So the integral is the area. That's all I want you to know, but in particular, if you turn it upside down, it becomes really negative 10 2/3. If I swap the numbers around, instead of going 32 take 21 and a third, it becomes 21 and a third take 32. So it becomes a negative. So swapping becomes negative, upside down becomes negative. So this is actually saying to us the area underneath the curve, but it's a negative. What about this one?
It's the same.
10 and 2/3?
Yeah.
So it removes the negative out of our final calculation.